Ladies and gentlemen, thank you for your patience in holding. We now have your speakers in conference. Participation in this conference call is by express written invitation of the AHA only. Unauthorized participants and or any party that aids and abets such unauthorized participants may be subject to criminal and civil penalties under both state and federal law. Please disconnect from the call or log off the webinar if the AHA did not expressly invite your participation. Please be aware that each of your lines are in a listen-only mode. At the conclusion of today's presentation, we will open the floor for questions, and at that time, instructions will be given as to the procedure to follow if you would like to ask a question. You may also ask a question at any point using the chat pod located to the right of the slides. A copy of the slides can be downloaded from the resources pod located directly above the chat pod. I would now like to turn the conference over to Sun Cao. Sir, you may begin.
Thank you, everybody. Thank you for participating in today's Lunch and Learn webinar, Healthcare HVAC Control 101 on Standing Airflow Valve Option for Critical Environments. Today's Lunch and Learn webinar is sponsored by Johnson Controls. The webinar will be recorded and posted to ASHI On Demand Learning webpage. All participant lines are muted. If you have any questions during the webinar, please type your question in the chat box, or we could take your question over audio at the very end of the webinar. Today's speakers are Beth Mankermeyer and Joseph Patai. Beth, would you like to kick us off?
Yes, thank you, Sun. So thanks, everyone, for joining me today. My name is Beth Mankermeyer, and I am joined by Joseph Patai and Caroline Moore, all with JCI, and we are going to talk to you today about the critical environment air valves. So our learning objectives today are to identify the mechanical and technological differences between VAV boxes, venturi air valves, and measured airflow valves. And then we're going to distinguish the features and benefits of each of those. And then we're going to recognize the best application for each of those. And this is how we're going to do it. We're going to start just with a critical environment overview, so we're all on the same page. And then we're basically just going to go over definitions and then capabilities and considerations for for all of the airflow valves. And then we're going to get into the applications, and then you'll see a really good review box there at the end. So let's start, just so that we're all on the same playing field, with what a critical environment is. All of these show places where we exist, anywhere where directional airflow is important and critical. And so to give you a few options for these spaces, first we start out with an operating suite. And you'll see on this slide all the products from a controls and ventilation standpoint that go into controlling this space to keep those occupants safe. And so you see everything from the overarching building automation system down to a very small door switch sensor. And additionally, just going into the other side of the coin in a laboratory, you'll see things like Parasite-coated venturi valves and also some similar things like a door switch sensor. So we're going to be going over these valves in their definition and also looking at when you would want to use one over the other. So let's get started. Here's the real meat and potatoes of the presentation here. We're going to start out with damper style valves, or as they're commonly known as VAV boxes. So these usually have a blade style damper, which you can see in a few different views of this VAV box. And you can also see that there's a flow cross present to measure the airflow. So in these VAV boxes, you are going to have measuring airflow. The air is going to go through that flow cross, get measured, and then it's going to send a signal to this actuator to open or close to control the airflow into the zone. So you would use these when you're trying to control the volume of air to zones, controlling temperature, humidity. And so these are really great for places like offices or auditoriums or shopping centers where you don't have critical needs, where you might have a temperature, you might say, hey, it's a little cold in this restaurant, let's turn the thermostat up, and it's not critical that it gets to that temperature set point very quickly. It can be very slow. And so these do, in that regard, have standard actuator speeds. And so you might have an actuator that is open to close, a 90-second full stroke actuator. So once again, not suitable for a critical environment, but very, very suitable for non-critical spaces. So here's a little animation to show that airflow and how it gets measured and goes through that damper blade. And that damper blade can open or close depending on the needs of the space. So there are some really good capabilities of VAV boxes. It is the least expensive option of what we're going to talk about today. And you can put a lot of airflow through these valves because of the shape of them. It's a very wide cylinder, so you can get some good airflow through. And it is simple, non-critical air controls. So it's the simplified, you don't have to deal with any kind of complex sequences or anything like that. And a really good capability is that the installers are usually very familiar with them because they go into a wide range of spaces. So it's always good to have someone show up on the job site and know right away how to install these things. So with the good comes some of the bad. So there are some considerations with VAV boxes, and especially you're going to hear me talk about these with regard to using them in a critical space. So they do have a time delay, and because they are actually doing the air measurement and that there are constant pressure changes within the duct, you're going to have this constant state of readjustment. And what that also means is that your actuator is going to have some more wear and tear on it. Since it's constantly measuring this airflow and sending signals to the actuator, your actuator will get more use out of it. The other considerations are that the flow cross can become blocked. So depending on where this is or how good the filtration is in the duct, or if there are filters between the zone and a return valve, let's say, you could have a potentially dirty condition where that flow cross can easily become blocked. And a real downside to that is when that gets blocked, the VAV box is not smart enough to think, you know, this is just debris getting in the way. That flow cross will get clunked up with dirt and debris, and what it'll think is that it's not getting enough air. So that blade is going to open to try and get more air, and then what you're left with is a really inefficient system. So because of that, it must be cleaned often to operate correctly. And so you're going to have higher maintenance costs. You're going to have people go in and clean those in order to operate accurately and effectively. And what you might also have to do, since there are sensors involved, you might have to recalibrate some sensors or replace some sensors because sensors do drift over time. And you might even want to look at how accurate the sensor is that you're using at the airflows that you need, because a lot of times those sensors operate very accurately at the 1,000 CFM level, but if you want to turn that down to 200 CFM, the level of accuracy can be off significantly. So if you're going to use something like this in a critical environment, which you'll hear me say don't do that a lot during this presentation, but if you were to do that, there's usually very strict guidelines and protocols for cleaning inside those critical spaces. So you would have to wear the proper the protective equipment, the PPE, and you would have to tent yourself off, and you might have to shut down critical spaces like patient isolation rooms or operating rooms in order to clean these out. And that's just going to impede your daily use of that facility. And the other downside to a VAV box is the low turn-down ratio, meaning you do not have precise control at the low or the high end of those CFMs on that VAV box. And so that can have so many implications, meaning you can actually, if you want to turn down for a night setback, if you want to get into some lower airflows, you might actually flip the room. Like, let's say you wanted to have this positive operating suite and you use the VAV box, it could easily flip the room into a negative room, and then guess what? You have to actually completely decommission that operating room to clean it out and recommission it to make sure that it is in the proper positive airflow scenario. And last but not least is a slow speed of response. I already spoke about the standard speed actuators with these. So you could have at least a 90-second full stroke. And like I said, in a place like an office space, it doesn't matter, but in a critical environment, it absolutely matters. So this slide is going to show you that important point about debris collecting on that flow cross, and you can see that damper blade opening. But your building automation system is going to see the exact same flow because it's only going to see the pressure change within the flow cross and think that it needs more air. So in turn, your building just runs very inefficiently. So here we have a little audience participation. We have our first poll question. So if you all are watching, I invite you to participate in this poll question. How familiar are you with Venturi air valves? And we'll give you guys a couple seconds to answer that. And we have Brandon on the other end who's managing the poll so that you guys can all answer that.
Are you ready to end it?
Yeah, let's go ahead and end it and see how familiar people are with Venturi air valves.
Sure. We had 27% unfamiliar, 68% familiar, and 4.5% very familiar.
Okay, great. Well, thanks for participating in that poll. We always like to get a little audience participation. There's going to be another poll question, too, coming up. So here we are getting into Venturi air valves. And so it's nice to know that there are some people on this line that are unfamiliar that we can introduce you to them. As you can see, they look quite a bit different from a Venturi, or I'm sorry, from a VAV box. They have a cone and spring assembly in the middle that you can see that actually, it kind of just looks like a toilet plunger, for lack of a better term. But what you have here, it does modulate the airflow just like a VAV box. However, what you have is when that cone and spring assembly is all the way out towards in this middle image here, when it's pushed all the way out to the right, you have a greater opening around that cone, and so more airflow can come through. And then conversely, when that cone is pushed all the way into that Venturi shape, which is this concave shape here, then less air can go through. So it's very similar to a damper blade where all you're doing is controlling air, but very, very different in how it can do that and its capabilities. So it is a highly accurate flow metering device. And what I mean by metering is that this is not going to measure airflow. It gets calibrated or characterized based on the airflow and pressure range that it will be operating in. So that's very important, and I could honestly go into an entire talk just about how it gets metered. So if you do have questions about that later, I'm happy to connect with you. I encourage you to reach out to me and we can talk about that. But just know that these do not measure airflow. They meter airflow. And so they use this dynamic cone and spring assembly, the thing that looks like a toilet plunger. And what happens is this spring gets so carefully calibrated that it's actually mechanically pressure independent, so that when any pressure changes happen within the duct, what happens is this spring will compress or release based on those pressure changes, and you keep your exact same volumetric flow. So to put that in a different way, your pressure is changing, but your CFM stays the same when you do not want it to change, right? So the other way that it controls air is to move based on this actuator. So one example of that is when you're in a laboratory, if you walk up to a fume hood and you raise the sash, you want this to open very quickly so that you can have more air go through that fume hood on a VAV system. And so the entire assembly would move, not just the cone and spring. So these are going to provide extremely accurate flows. It's within, the guarantee is within 5% of flow. However, when these come off the assembly line, it's more like 1% of flow. So they are extremely accurate and have repeatable control. And on these, they do have fast-acting actuators, and they do have standard actuator options if you do want to use it in a tracking pair situation. But for the critical environments that need to react very quickly, there's those fast-acting actuators. So on a VAV box where you had at least 90 seconds, these would have about 3-second full stroke actuator options. And so here is an example of how that cone and spring assembly moves with the actuator. So this is actually changing the flow. And we're going to see how these operate. So in this slide, we're seeing the pressure change in that little gray box in the top. And you see how only the cone and spring assembly is changing to change with those pressure changes. So in this example, the CFM would stay the same. So call out a CFM number, let's say 500 CFM. It would be 500 CFM the entire time that this cone is moving. It's just moving with pressure changes within that valve. Now here we have where we have the airflow control demands changing, and so the airflow actually is increasing as that cone and spring assembly moves towards the left end of the screen. So the airflow is hitting the cone, it's going the direction of that arrow, and the cone and spring assembly is moving to the left to account for more air going through that valve. And now we're going through the capabilities of the Venturi valve. They have a very high turn-down ratio. So in terms of comparing these to VAV box, there's really no comparison. The Venturi valves, they allow you to have very precise control at the lower end, the middle, and the upper end. So the entire curve of the entire flow curve on these Venturi valves, you're able to have very precise control, like I said, within that 5% of your flow set point, but also could very well be lower than 5% accuracy. So, or lower than 5% inaccurate. So they are maintenance free, meaning since you're not measuring anything and you don't have any sensors, you don't have to maintenance anything. And these could last for years. I've seen some Venturi valves that have been installed for 20 years and they're still working. So what happens is if anything does get caught around that cone and spring assembly, the velocity of the air is usually so fast such that it will be self-cleaning. And so that's really nice. You don't have to go in and recalibrate anything. And with that pressure independence, it will change for any kind of changes in that duct, in the pressure changes. Along with that pressure independence, you have inlet insensitivity, meaning you don't have to have completely straight air going through these valves in order to operate correctly. So you can put these after a 90-degree elbow and you know that it's still going to work correctly. Whereas if it were measuring airflow, it wouldn't be able to do that. And the other really great thing about Venturi valves is that they're available with options specifically for critical spaces. So coatings, like what you see on the top Venturi valve there, that's a Harrisite, which is a phenolic coating. So really great for fume hood exhaust. And then there's stainless steel or insulated valves. And then the one that you see in the middle is a ganged valve. So if you have higher airflow requirements, we can actually gang those too. So along with the pros come the cons. There are some considerations with Venturi valves that obviously cost is going to be increased. It's a more sophisticated piece of equipment than a VAV box. So it is going to cost more. The other thing about Venturi valves, because it does have that cone and spring assembly, it requires a minimum differential pressure across the valve for that to engage. So there are different numbers, but there's a low pressure valve that requires 0.3 inches water column, and then there is a medium pressure valve that requires 0.6 inches. They go up to 3 inches, but if you get out of that pressure range, then the Venturi valve will go out of calibration because it's not going to be calibrated for anything outside that range. So what that means is it doesn't just drop right off of calibration, but you're going to be outside of that guaranteed 5% range. The other thing about Venturi valves is that we are specific to valve orientation. So the part number is going to say, okay, are you installing this horizontally? Are you installing this vertically? Are you installing this vertically up or vertically down? And so your part number is most likely going to have something to show where it's being installed. The other consideration is without a differential pressure switch, which is an option that you can add, and I do encourage people to specify differential pressure switches on these. But without that, or without a fume hood sidewall sensor, the airflow is assumed. So you could have a fan failure, and if you don't have a differential pressure switch, you could have a real problem on your hands. So I encourage you to either specify a differential pressure switch, or if it is on a fume hood, make sure that that's a closed-loop fume hood control system with a sidewall sensor. Another consideration is just that less flow is allowed due to that venturi shape, and so that's just looking at sizing, and it's an easy workaround, but it is something to consider. So now we're going to measured airflow valves. And unfortunately, there isn't really an industry standard term for these. And so this is going to be comprised of a lot of different valves that we're going to look at. And so we are referring to valves for use in critical spaces, and they are going to be measured. But as you're going to see, there's going to be a broader definition range for these. So with these, there are many ways in the industry to measure airflow. And so you're seeing one right here, that there are two different pickups where it's taking a differential pressure and it's going to send a signal to the actuator to move this blade. These are not mechanically pressure independent. Because they don't have that cone and spring assembly, they do rely on the measurement of the air to send a signal to the actuator. So they are not mechanically pressure independent. They are, just like a venturi valve, offered with fast and standard speed actuators, but those damper blade styles really vary from model to model. So there's a lot of gray area when we're looking at those blade styles. And here's some other types that are on the market, just to give you guys some more insight into what those blade styles look like. So here are the capabilities of those measured airflow valves. We've got higher turn-down ratios than a VAV box, but they really vary. So some of them vary from lower than a venturi valve to higher than a venturi valve. And so you just do need to take a look at the measured airflow valve you're looking at to make sure that it fits your needs. But a really great thing is that they operate on low differential pressures because you don't have a cone and spring assembly, they don't have that minimum differential pressure in order to be highly accurate. These are also available with options for critical spaces, just like a venturi valve. And a really great thing is that they're not specific for orientation. Once again, that cone and spring assembly gets calibrated on the venturi valve specifically for an orientation, but you don't have that on these valves. So it might make your installation easier. It might make just project management a little easier. And because of these shapes, some of them, kind of keyword, most of these types have more flow than a venturi valve, but also some of them have a venturi shape, so you run into some of the similar things. So you really do just have to be a consumer and take a look at the product data sheets for what you're looking at. So here's another animation showing one of these types. This type, in order to help with the turn-down ratio, this does have air fins that compress against the shell in order to have precise control over the low and high ends. And as mentioned, this one does have two pickups that take a differential pressure reading in order to take that airflow measurement. So when we're looking at considerations of these, they are going to be still more expensive than a VAV box, but since there's a wide range, you're going to have prices that have a wide range. And your measured airflow does result in a lag because you are taking a measurement of that airflow, and it's not going to react instantaneously. It has to send a signal to the actuator. The actuator has to move the blade. And since there are sensors involved, they do have that potential sensor drift. Sensors do drift over time and when they're used. Depending on the sensor you're using, some are worse than others. Sensors, it's like having a brand new latex balloon and blowing it up and then letting the air out. That's like what happens to a sensor when it's working. It's never going to go back to that exact original shape. And so because of that, you will experience drift. They are mechanically pressure dependent, so you don't have that cone and spring assembly like on a venturi valve, and therefore any pressure changes within that air valve, it's going to get measured within that airflow measuring function, and therefore that blade will try and hunt to find the right spot for what needs to happen within that duct. And so you really need to look at how airflow is being measured. Is airflow being measured with a flow cross that would have the same issue as a VAV box, where you could get dust and debris in there? And like we saw that animation at the beginning where the debris caked onto the flow cross and then that blade opened. And yet your building automation system sees the same flow, so you don't know there's an issue. So you really need to be a consumer and figure out how that airflow is being measured, because if it's in the airstream, that's really tough in a critical environment. You don't want to have to go in there and clean anything out. You really want it to be maintenance-free in terms of how it's measuring airflow. And also, because they are measuring airflow, the inlet is sensitive in most cases. You don't want to put these right next to a 90-degree elbow unless you know that air has been straightened out with some kind of air straightener, or that the function of the airflow measurement accounts for that. So you really want these to install these into straight duct lengths. So here we're going to get into some more of the design differences and put them right next to each other so that you see VAV box there on the left, Venturi air valve in the middle, and the measured airflow valve on the right. So the big things, the VAV box has that flow cross in the airstream, and the standard blade has that very low turn-down ratio. And then in the Venturi air valve, it has that very unique pressure-independent cone and spring assembly, and the fact that it does not measure airflow. It gets fully calibrated at the factory. And then on the right-hand side there, we have the measured airflow valve, which you need to be a very good consumer and look at how is it measuring that airflow, and what is that blade design to make it have a higher turn-down ratio. And so speaking of turn-down ratios, we do have a graph showing. With a VAV box, it's got about a 3-to-1 turn-down ratio, meaning when you open up that VAV box, that blade opens up just a little bit, you're going to get about 30% of that flow. And that, if you're working in a critical space, you need to have control within that 30% of flow. So you see this Venturi valve has a 20-to-1 turn-down ratio, where the graph goes a lot more, it does not raise as quickly as that VAV box. In fact, it raises very, very slowly, so that you have the precise control over both the low end and the top end. So here we're at our second poll question, which is, which valve type have you worked with the most? So I'll give you guys a couple seconds to answer this poll question, and then we can see what you guys have. Alrighty, I think we probably got some good responses. Brandon, what did we find out?
85% VAV box and 14% Venturi valve, no options for the measured airflow valve.
Alrighty, great. Well, hopefully you guys are learning some fun things today that, that you'll maybe find some new applications for the Venturi valves or those measured airflow boxes or valves. So now we're going to get into some applications, and because there's really room in this world for every one of these valves that we're talking about. Right here we have a patient isolation room that might be positive or negative with respect. So we have the isolation room right here, an ante room right here, the restroom right here, a corridor, and then we have a non-critical space like a meeting area, a conference room. And so you can see that in this space there's a VAV box in the non-critical, and then you'll have this return air right here. And you might have measured airflow valves located in the patient room and the ante room because of pressure requirements, and you might have Venturi valves on the exhaust side. So it really just depends on what the pressure is within the space, how you want to control them, and what the goals are for the space. And so adding to that, you might have, so these are the spaces we just saw on the previous slide. But adding to that, you know, we might have another type of meeting area here, an operating room, and a laboratory. So you can see the other options as well, where we have Venturi valves in the lab, and you have those parasite-coated Venturi valves. Venturi valves are really great for lab exhaust because you want that user to stay very safe at the face of that fume hood. And since they can change immediately with changes in pressure, it's a really great solution for a fume hood lab exhaust and supply. And then right here we have this operating room where we've got Venturi valves featured here as well. You might be able to use the measured airflow valves if the pressure requirements are lower than what you can get with the Venturi air valve. So it really just depends on the situation and what you have. So one thing that I do want to point out, though, in something like an operating room where you are needing to have so many air changes, like about 20 air changes per hour when that's in operation, that's a lot of energy going through that room. It's a lot of cost for a hospital. So if they would want to have a scenario where they have a night setback or a turn down when it's not in use, but keep that space in positive pressure because you don't want any bugs getting in, right? Then you definitely want to look at something that has this high turn-down ratio, like the Venturi air valve or the measured airflow valve. And you can use them as a tracking pair situation where they are being controlled based on your volumetric offset, and you can turn that down. And so you can experience your lower air changes when it's not in use. And because of these valves having such a high turn-down ratio, when someone walks into that room gets up and running immediately. And so that's a huge benefit to having that high turn-down ratio with the Venturi air valve or the measured airflow valve. And so here's another situation just showing mixing and matching where your duct pressure, so here's an example of an exhaust fan. So obviously your pressure is going to be greater closer to the exhaust fan. So these trunks with green on them are for a valve that has a wider operating range than a Venturi valve. So if it goes above 3 inches, and then in the lower end where the pressure is very low down here, the furthest away from the exhaust fan, you might need to use the measured airflow valve for the critical space down here. And then in between you can use Venturi valves. So it's one of those things where you definitely can mix and match within a system. And then we also have this example of a space where you can see all the directional airflow required with these arrows and numbers. And so you have your tissue culture labs here, and all of this, there's open labs, a bunch of tissue culture labs, but then you have all of these spaces over here where directional airflow doesn't matter. They're office spaces, and you have conference rooms. And so this is another example of a way to mix and match. And I have also seen, if this were a hospital, that you can actually choose to use these critical valves for every space to make it pandemic ready. And so that's extremely relevant, especially in today's world where, you just don't know how many spaces you might need to precisely control the airflow through that space in order to increase your rooms, your patient rooms. We've seen this in a couple cities that have really needed to increase their hospital patient rooms in a very short amount of time. So here we are wrapping it up. Here are the design differences kind of in a nutshell for the VAV boxes, the Venturi valves, and the measured airflow valves. Really the bottom line here is VAV boxes, we would not recommend them for the critical environment. They're absolutely appropriate in other spaces, but if you're going to use something in a critical environment, you can not only experience better energy savings by using these Venturi valves and measured airflow valves, but you have that precise control, and the hospital is going to have better control over keeping the positive spaces positive and the negative spaces negative. And so that's really a big deal when it comes to maintenance costs and looking down the road at your building efficiency. So I really want to thank everyone here for your time today, and I do want to open up the floor for questions. I do have Joe with me as well to help answer some of those questions. So fire away if you have any questions on what you just learned about.
Thank you. At this time, we will open the floor for questions. If you would like to ask a question via the phone, please dial *1 to enter the queue. Again, that is *1 if you would like to ask a question via the phone. You may also ask your questions utilizing the chat box located to the right-hand side of your screen. Simply type in your question and press the Enter key. We do have several parties typing in the chat box at this point. We have a comment, great information. Thank you for your presentation. And we have another question. Can you use a measured airflow valve in an OR?
Yes, the answer is yes, absolutely you can. So what we would recommend, if a Venturi valve works, we would probably recommend to go with that first just because it does have the pressure, the mechanical pressure independence. But what you could do is use those measured airflow valves as a tracking pair, and you would have them programmed to have a volumetric offset, and you would be able to use those in an operating room. And they would have the turn down ratio that would be appropriate, the higher turn down ratio. And so you'd want to make sure that it has the high turn down ratio that would fit the design.
Thank you. As a reminder, if you would like to ask a question via the phone, that is *1, or you may type your question in the chat box. We have another question. Can the measured airflow valve be used for both supply and return?
Yes, absolutely. In fact, yeah, I would match the type of valve that you have for the supply and the return, and you would absolutely be able to use those. And Joe, do you have anything to add to that?
No, that's typically we always either put two measured or two metered valves, one on supply and one on exhaust. And that's the way you do a tracking pair and control the room pressure, the relative pressure.
We have another question. Between airflow valve and Venturi, which of these has low noise?
So that's a great question. I would encourage that person to actually ask for the information from the manufacturer, because I don't want to speak about noise in a generic way for the measured valves, just because there are so many different designs out there. So it's very hard to kind of put a blanket statement. But there should be sound reports from the manufacturer that you can ask for. And so I would just encourage you to ask and compare in that regard.
We have some thanks here, but we're holding for questions currently. Another question, what is the curve for the measured flow valve?
Sure. So if you're asking about the turn down ratio, those also vary, but it would look more like the Venturi valve curve. So it would have a higher turn down ratio, but since those do have wide ranging ones, I didn't put a line on the curve for that. But that's a good question. It would be another thing that if you're looking at a specific valve, you can ask the manufacturer to provide you with that turn down ratio for those valves, and they should be able to do that for you.
Thank you. A quick reminder, if you're on the phone and would like to ask a question, that is *1 to enter the queue. I'm showing no further questions on either side at this point.
Okay, well, I just want to take this opportunity to thank everyone again, and please reach out if you have any other questions. Like I said, this was a lot of information to go over in a short amount of time, so I hope you all learned something and can apply it to your future projects.
Thank you, ladies and gentlemen. This concludes today's event. You may now disconnect your lines, log off the webinar, and enjoy the rest of your day.